Today we will talk about acceleration. We'll talk about motion with constant acceleration. Before starting today's lesson, let me repeat what we did till today. Let's summarize it quickly, shortly. Till today we studied about motion with constant velocity. Basically we call it uniform motion. In this case, it's very simple. We have only one equation, distance equal to velocity times time. Or you can write it in terms of position, final position equal to initial position plus velocity times time. You can use one of these two equations. Basically, these two equations are same. The first one is given in terms of distance. In second case, the same equation was given in terms of positions. Basically, distance equal to final position minus, you need to subtract initial position. Of course, we have only one equation, but in some problems it can be given or it can be solved in different ways. Graphic method, yes, for example, position, time graph, we usually use. In this case, for example, if you have a uniform motion, if you have a motion with constant velocity, then you should expect straight line. For example, like this. This is a straight line. And we explained about slope. Slope is a tangent alpha, or gradient, sometimes we call it. For example, as you see, the angle, this slope is constant. So from here, we can understand that this graph corresponds to uniform motion with constant velocity, for example. And for example, initial position is not equal to 0, yes, as you see, because 0 is here. In this way you can describe problem in terms of graphs. Also, you can use velocity time graph. Velocity time graph. For uniform motion, you should expect straight line, horizontal straight line, because velocity is not changing. Horizontal straight line, for example, like this. And sometimes, not sometimes, you can use this area to find out the distance that certain object will move. So for example, area will give you the distance equal to distance. But you should be careful. You can use this one only if you have a velocity time graph. So if you have a velocity time graph, the area under the line will give you the distance. The slope, if you have a position time graph, then slope or tangent alpha will give you velocity. Yes, we explained it already. So this is the main two methods that you can use when you solve the problem with graph methods. Now, let's consider different case. Let's consider when car moves with varying velocity. For example, at certain time, at initial time, let's say at 0 second, velocity of this car was equal to 0, for example. After 1 second, let's say velocity becomes 3 meters per second. After 1 second, basically after 2 seconds, velocity becomes, let's say, 6 meters per second. And after 1 second, it means at time 3 seconds, velocity becomes 9. So what we can see from this diagram? Yes, what we can see in this diagram. So first of all, don't pay attention to the size of the arrows. Don't pay attention to the size of the arrows. This is not for scaling. It's not for scaling. So what we can see, we have a car starts accelerates basically to the right side. So each second, velocity increases. And what we can say? We can say that this car is accelerating. So here we can use this term, physical quantity, we introduce acceleration. So basically acceleration is motion with changing velocity, varying velocity. And we can notice that each second velocity changes by 3. So here initially it was 0, after 1 second velocity increased by 3, after 1 more second velocity again increased by 3, after 1 more second velocity again increases by 3. So what we notice here, each second velocity increases for certain constant number, yes, for certain constant value, and we call it acceleration. For this problem, acceleration equal to 3 meter per second square for this specific problem. So now let's study the unit for this acceleration. So we said meter per centimeter, meter per second square. So we can write it in this way, meter per second, basically. It's the same thing. So if you pay attention, meter per second is a velocity, second is a time. So basically acceleration is velocity per time, per second. So we can conclude that it's simple that from this example we can see that V1 minus V0 divided by T1 minus T0. Yes? What is the V1? This is a velocity at 1 second. V0 is a velocity at 0 second at the beginning. T1 is a time at 1 second. T0 is a time at 0 second. So basically we have this kind of equation and it will give you 3 meters per second square. Or you can use another equation, for example, velocity at 3 seconds minus velocity at 2 seconds divided by time at 0.3 minus time at 0.2. So again we will have same result. So 3 minus 2, we will have 3 meters per second square. So for this problem, we have a motion with constant acceleration because acceleration is not changing. At the beginning it was 3, at the end of its motion again acceleration is 3. So this car is accelerating with constant acceleration, and this acceleration equal to 3. This was just example. And we showed how to use how to calculate acceleration. So final velocity equal to initial velocity plus acceleration times time. We have this kind of equation. You can remember it, you can memorize it, but I will advise you the method how to remember this equation quickly. So let's give the same example. At 0 time, velocity was equal to 0, for example. After 1 second, velocity becomes 3 meters per second at 1 second. Yes. So basically, after 1 second, velocity becomes 0. Yes. So what we did, we basically V1 equal to V0 plus acceleration times 1 second. Basically, we can come up with this logical equation. So 3 equal to 0 plus 3 times 1, and 3 equal to 3. Now let's say after 1 more second, velocity becomes 6 meters per second at 0.2, which is after 2 seconds basically. So let's use this equation, V final equal to V initial plus AT. So after velocity becomes 3 after 2 seconds. Yes. So let's check. Velocity at 0.2 equal to initial velocity. Let's say initial point 0 plus A times t. 6 equal to initial velocity 0, acceleration 3, time 2. As you see, 6 equal to 6. So our equation is correct. Or let me explain in different way. Maybe it will be more useful. So what is acceleration? Acceleration is a change in velocity. So basically you need to add acceleration to the initial velocity to get velocity final. So after 1 second, initial velocity 0 plus 1 acceleration. Yes? Or let me write it in terms of symbol. V initial plus acceleration after 1 second. Yes? So it will be equal to 0 plus 3. Velocity after 1 second will be 3. So after 1 second, initial velocity before 1 second was V1. Again, we need to add acceleration because again, car is still accelerating with the same acceleration. So velocity 1 second before was 3 plus acceleration again 3, it will be 6 meters per second. Velocity at point 3 equal to velocity at point 2 plus 1 acceleration because velocity 2 is a velocity 1 second before. So it will be again 6 initial velocity for this case plus 1 acceleration, it will be 9. So if you combine these three equations, you will get this kind of equation. For example, V3 equal to V initial plus 3 times A. 3 times A, as you see. So this 3 is a time after 3 seconds. Yes? So we can conclude that final velocity equal to initial velocity plus acceleration times time. So this is a very important equation and you should remember this equation. This is the first equation and we have 2 more equations. Now we will prove it. Now let's draw graph for this equation. Now we can draw graph. We have this equation, final velocity equal to initial velocity plus a times t. If you pay attention, this is a linear equation. So it means we can draw graph for this equation because it's simple equation, linear equation. So you will have this kind of straight line for velocity time graph. Why I'm drawing plotting velocity time graph? Because this equation is velocity equation. So here of course this will be initial velocity, this will be final velocity, and this will be time. Yes, of course here is 0. By using this graph you can solve these problems. So now we have a straight line, and if you pay attention, the slope of this graph is constant, and as you know, slope equal to tangent alpha. Yes, for this problem, what is the tangent alpha in terms of geometry? For example, you can draw this kind of triangle to find tangent alpha. Yes, right triangle we have. What is the tangent alpha in terms of geometry? This part, which is v final minus v initial, divide by time. This part is basis time. So tangent alpha equal to v final minus v initial divided by time. Yes, this is in terms of geometry. Now let's come to this equation. What is acceleration? V final minus v initial divided by time. As you see, we have exactly the same equation. So for velocity time graph, slope equal to acceleration, or let's say tangent alpha for velocity time graph. Only for velocity time graph, slope will be equal to acceleration. So this is something that you need to know. So velocity time graph, slope will give you acceleration. So let's give simple example. We have a velocity time graph, and we have two cars moving with different accelerations. Let's say this is a Camry, red one, and the blue one is Priora. Blue one, Priora. and we need to find out which car accelerates faster, yes, quicker, we can say. So since we have a velocity time graph, we can simply compare slope for red line and the slope for priora, for blue line, because this slope corresponds to acceleration. So visually we can see that this angle, this slope is smaller than slope for the Camry, for the red car. So what we can say, we can conclude that acceleration of Camry is bigger than acceleration of Priora. So if you pay attention, in this graph there is no any data, no numbers. But to solve this problem, we don't need any data. Just we need to compare slope for the red solid line and the blue solid line, and this will be enough to understand which car accelerates faster. If you pay attention to the previous equation, we have a relationship between velocity and acceleration. Now there is no any information about distance. Yes, if you pay attention to this equation, you cannot find distance by using this equation. So what we need to do? We need to come back to the original equation. What was the original equation for velocity? Velocity was equal to delta x over delta time. Yes, so basically you need to derive distance with respect to time. So by using this equation we can find distance. So let's see. So delta x equal to velocity times delta time. So we need to take velocity from the first equation and substitute into this equation, and let's see what we can get. Delta x equal to v initial plus acceleration times time and delta t. This is basically integral equation. This is integral equation. So x equal to, let me write separately, v initial times delta t plus integral at delta t. X equal to v initial times time. Here we will have at square over 2, and of course there will be some constant number, and this constant number is basically initial position. So this is a final position equal to c is the initial position plus v initial time plus at square over 2. We have this kind of equation. If we pay attention, we can remove x initial position to the left side, so we will have this kind of equation. Final position minus initial position equal to initial velocity time plus at square over 2. So this part actually, final position minus initial position equal to distance, as you know. So distance will be equal to initial velocity time plus at square over 2. This will be our next equation. As you see, we have equation for distance. Let me write here our two equations that we can use for motion with constant acceleration. So first one, final velocity equal to initial velocity plus at. Second equation, x equal distance equal to initial velocity time plus at square over 2. So if you pay attention, this first equation, this is the relationship between velocity final and the velocity initial and the time. Second equation, this is the relationship between distance, initial velocity, time, and of course acceleration. But there is no relationship between only velocities and the distance. So actually we can find it by using these two equations. So what we will do, let me find time from the first equation, and it will be equal to final velocity minus initial velocity divided by acceleration. And let me substitute it into the second equation. I will replace time with this one. So first of all, let me rewrite equation number 2. We can take time outside of the bracket, so we will have this kind of equation, AT over 2. Also, we can write it in this way, 2 times V initial plus AT divided by 2. Let me continue it again. In this way, x equal to time. So this part we can say V initial plus plus AT divided by 2. If we pay attention, this part equal to final velocity. This is basically first equation, yes? So V initial plus V final over 2. So now let me take time and let me replace it with this equation. So x equal to V final minus V initial over 2. This is the time. We need to multiply it by, sorry, there is a mistake. It's not 2. We need to divide by time. Yes, time. We need to multiply by V initial plus V final over 2. Sorry, here it's not time. It should be acceleration. Acceleration, yes. And V final minus V initial times V initial plus V final over 2A. So this part is simple math, A minus B plus A times A plus B. So we can write it in this way. Final velocity square minus V initial velocity square divided by 2A. So from here, V final square equal to V initial square plus 2AX. So as you see, no time. We remove the time, and we obtain a new equation. This is a relationship between final velocity, initial velocity, and the distance. Now let's summarize. We have 3 equations for motion with constant acceleration. So be careful. You can use these 3 equations only if you have a motion with constant acceleration. When you have a motion with unvarying acceleration, velocity changes but with constant acceleration, only in this case you can use these 3 equations. So let's start. V final equal to V initial plus AT. This is equation number 1. Бірді белгіледік. Екінші теңдеуімізді жазамыз. Final velocity square initial velocity square plus 2 acceleration times distance. This is equation number 2. And the last one, distance equal to initial velocity times time plus 1 over 2 AT square. This is the equation number 3. We can use these 3 equations to solve problems related to the motion with constant acceleration. And here you can use negative sign in the same equations if you have a deceleration. Deceleration means motion with decreasing velocity. With decreasing velocity. If you have motion where velocity decreases, then you can use these 3 equations but with negative sign. Graph methods: velocity, time, acceleration, time. Also we can use distance or position, time, graph. When we have a motion with constant acceleration, then velocity will be straight line with constant slope. For acceleration time graph, it should be horizontal straight line because acceleration doesn't change. And for position time graph or distance time graph, according to the equation number 3, we can plot this kind of equation, this kind of graph. Because distance that car covers will increase because velocity is increasing. And some methods that you can use For example, for velocity time graph, this slope, tangent alpha or slope, will give you acceleration. We explained it already. And the area under the graph, velocity time graph, the area under the line will give you distance. This area will give you distance, but don't forget, only for velocity time graph. Area will give you distance. Slope will give you acceleration, area will give you distance. Now let's come to the position time graph or distance time graph. As you see here, this slope, tangent alpha or slope, is increasing, because this slope for position time graph will give you information about velocity. So of course, this is a motion with constant acceleration. It means velocity increases, so slope should increase. So this is what you should expect from distance time graph. Let's solve this question. First of all, read the question very carefully and try to understand. Second step, it's better to draw diagram, figure, picture, so we could solve it easily. So what we have a rocket sled's engine fire for 5 seconds, boosting the sled to speed of 250 meters per second. Basically, initial velocity 0. After 5 seconds, velocity becomes 250 meters per second. It accelerates basically during the 5 seconds. The sled then deploys a braking parachute, slowing by 3 meters per second until it stops. What is the total distance traveled? So first of all, when you read the question, the given of the question problem, you should highlight some very important informations. So here, what we understand, initial 5 seconds, it accelerates with acceleration, and this acceleration is unknown, but after 5 seconds, its velocity becomes 250 meters per second. We can understand that initial velocity equal to 0, initial velocity equal to 0. Then after 5 seconds, what happens? Velocity decreases with acceleration 3. This is acceleration, if you read it carefully, 3 meters per second. So basically this is a 3 meters per second square. Then it stops. Now we need to find total distance. So let's draw diagram. This is initial point. Let me call it point 1. Velocity here 0. Point 2, this is a point after 5 seconds, and the velocity here becomes 250. Time interval between point 1 and point 2 is 5 seconds. So basically it accelerates between 1 and 2. This is the direction of acceleration. Let's call it A1, and this A1 is unknown. Then we have a point 3 when it totally stops. So let it be somewhere here, point 3, and we know that velocity will decrease and becomes again 0 because it stops. Here stops. With acceleration here, direction of acceleration will be negative. Negative means will be directed to the left. That's why velocity decreases. So this is the direction of acceleration. Let's call it A2, and this A2 is given 3 meters per second square. Y direction is opposite to the velocity. Only in this case, velocity will decrease and it will stop. So question, we need to find total distance. Distance between point 1 and point 3. So as you see, we can divide this question, this problem, in 2 different parts. First part is 1 and 2, the trip between point 1 and 2. Second one, it's a trip between point 2 and 3. In both cases, acceleration is constant. In first part, it accelerates. In second part, decelerates. Deceleration means velocity decreases. So let's write some equations, and we'll see which one will be useful for us. So let's start from let's write some equations for points 1 and 2. We can write 3 equations. So final velocity v2 equal to initial velocity v1 plus acceleration a1 times time. This is the first equation. Maybe it will be useful. Let's see. Final velocity 250, initial velocity 0, acceleration unknown, time 5. As you see, from here we can find acceleration. And this acceleration equal to 250 over 5, 50 meter per second square. This is a acceleration. Then let's write second equation for the points 1 and 2. Let's start from the final v final square equal to v initial square plus 2a1 x, let's call it x1. So this distance we call it x1. For now it's unknown. Final velocity given 250 square, initial velocity 0 for this part, 2 times acceleration 50 times x1. So from here x1 will be equal to 625 meters. This is a distance between point 1 and 2. Now let's write some equations between point 2 and 3. So what we have: initial velocity given for point 2 and 3, final velocity given, acceleration given. So we need to find distance. So let me call it x2. Also unknown. Let's write equations between point 2 and 3. I think it's better to use equation number 2. Final velocity square equal to initial velocity square, which is v2 minus 2 times acceleration times x2. Why I use it minus sign? Because of deceleration, because velocity decreases, that's why we use negative sign. Final velocity 0, initial velocity for point 2 is 250, acceleration is 3 times x2. So x2 equal to, from here, approximately 10,416 meters. This is a x2. So question was, so we need to read question carefully. What is the total distance traveled? Total distance means distance between point 1 and point 3, which is basically x1 plus x2. So x1 is 625 plus 10,416. So total distance will be equal to 11,041 meters, approximately 11 kilometers.